Hi, Professor and PA. This is my revision video for my homework 3, PS3. So, in total, there are three questions. And in the first question, my Python program passed all the tests. But I got some minor or like some mistakes in the second and third questions. So let's go into them one by one. The first one is my second, in my second question, in the first part is we need to calculate the exact runtime for two programs. My answer, the first is 4n plus 9, the second is 7n plus 13, as shown here. But actually, the correct answer is 4n plus 10 and 7n plus 14. The part um, so if we look into the program here, give me a second. So overall speaking, my calculation of the exact runtime is correct. But the only missing part of mine is that I forget to take into account of the extra time we cost when counter equals 0 to exit from the loop. Therefore, as you will see in my solution, the first is 7, the second should be the 4n plus 1 instead of 4n, and the last part is 2, so in total is 4n plus 10. And for second program, the first also, the 0 to 7 line should be 8, the second should be 7n plus 1 instead of 7n, and the final should be 5. So in total, it should be 7n plus 14. This is the first part. And in the second part, actually, the graphs I created is totally long. And when I look into my program, so as you can see here, I made some mistakes here. For example, in the subtraction, so this line is what I had in my homework. But actually, we need once we get the subtraction result, we need to float it to 0. So that should be what the correct answer should be. And also in my homework, I create the graphs finally looks like this. This is totally long. So the correct answer should be like this, right? The first program will increase in runtime exponentially, and the program 2 will increase in runtime like more like linearly. And the last part of the question is ask us to explain why the two programs differ in runtime. The main in total there are two because my answer may be not related to or like very in high level, right? Because not very specific because in the part B, the graphs I created is not correct. But if we I mean from starting from these correct graphs, there are two reasons that's why the two programs differ in runtime. The first is typically we assume that there are O1, I mean each operations, addition, subtraction, division, and multiplication. We all take the O1 operations. I mean O1 in runtime for each operation. But actually, in actual Python programs, for example, for the multiplication, the runtime really depends on the input size n. So in the first program, if we can look into here, the result will increase like unbounded. So it will increase in size from time to time and making our multiplication slower and slower. So that is the reason that the program 1 will increase in runtime exponentially. However, for the program 2, right? Every time we mold it, right? We mold it to we divide it over the W. So the W is 2 power to the 32. So which means that we keep our result bounded. In this case, we will not increase the input size, and which means as a result, our final result runtime will increase more like linearly. And also, another reason is that Python will or also in program 2, right? If we can keep our input size bounded within the 2 power to the 64, so which means that we can only use one word to store it. On the contrary, the program 1, if our result can increase unbounded, which means that Python will use more than one word to store this result. So this makes our program slower furtherly. So that's the overall. And the last part is what I have learned from this. So in the future, I will be more concerned about, for example, concerned about the any conditions, additional time cost. For example, we're not missing this exiting the extra runtime for exiting the loop. And also, another thing is that when I write the code, I will understand what we will do. For example, I will not missing that subtraction result flowing to zero error. And also, I will think more about, for example, the explanation makes more think more about why the Python takes more time in operating program 1 compared to program 2, because there are some like Python overhead and also taking into the account in the input size, right? So this is very important because when our computer computes numbers, we cannot simply assume that some operations will work linearly. Instead, we need to take more factors into consideration, for example, the input side, the output side, and also the whole process as a whole. So, and this is the question 2 takeaway. And also for the question 3, I still have some minor. So this is my question 3 answers. I also have some minor mistakes making here, but it's very minor. The reason is that in here, at this part, as a matter of fact, for the Go2, I just say that the RAM and word RAM are very similar with the Go2. But actually, the mistake I made here is that we need, because other operations, other commands may change, and also adding or deleting some lines. So actually, the line numbers will change in the whole program. In this case, we cannot simply go to K, right? So here we go to K, but actually the K line maybe not the original line. So we need to take this into consideration. We need to, for example, if other commands add a line, we need to go to the correct line we need to go to, instead of just replace, just copy and paste. So this is the mistake I made here. And in order to correct this, we just need to consider into the changes in the line number and go to the correct line. And the takeaway from this is that in the future, when I write, for example, if I need to translate one RAM program into word RAM, or like a word RAM program into the RAM program, so from time to time, I will keep in mind of the line numbers to make sure that there are no errors in this process. So that's all for my revision video. Thank you so much.